This video will cover how to set up a traditional VAV with district cooling and district heating in DesignBuilder. If you were to run a simulation now before adding the HVAC system, there would indeed be cooling, but it would not provide any real useful results because is essentially giving every zone a magic box that can perfectly meet the load regardless of the situation. But there's no pump speed, pump electricity, or fans, or specifications like that. So if you want to model an actual VAV or any system for that matter, you need to go up here to the settings and then move this slider from simple to detailed. And then we'll leave this on simple HVAC data for right now. We're going to cover that in a different video. Now, generally at this point, you would have this would be completely blank, but because I want to test something out before recording the video, it's not. So when you first load it up, you'll get something like this. It'll be completely blank, and when you click the HVAC system, it'll do load template. And you can pick different templates here. Right now, we're just going to pick the VAV reheat air-cooled chiller, and we're going to modify that for district heating and district cooling. So, click next, click all the zones that have this, which for this case will be all the zones. Click next, 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 and finish, and then override it. So I never changed anything in those settings, which is why I just kind of went over it quite quickly. You can look through it yourself if you want to, but generally, you're just going to do the things after the fact. So the first thing we're going to do is we want to change the boiler and the chiller into district cooling and district heating. So we're just going to double click. Went the wrong way. Or you can just go to the branch and go to supply side, click the chiller, delete the object, confirm it, and then add in district cooling. And then we're going to go up here and connect the components, and you can see these pipes have arrows, so just kind of line up the arrows, and there we go. And you can add more things if you want to, like you can have 2 or 3 things all working together, but generally it's only supplied by one thing. So we have district cooling, so you can either double click or then click on edit highlighted item, and the nominal capacity is pretty low, but there is a limit to how high the capacity can be. So for safety, just kind of add 3 nines and click OK, and that'll be that. If you run the simulation and you see that the cooling load or the cooling supply cannot satisfy the loads, just add another chiller, increase the value, and then connect them as you did into the in and out, and that'll let you have any amount of heating and cooling you desire. So we're going to do the same thing for the hot water loop. We're going to go to hot water loop supply side, delete the boiler, and add district heating. Well, you don't have to do this. If you have a boiler and you have a chiller on your building, you can use that. But I'm considering most buildings on Georgia Tech campus use the district heating and district cooling supply. We're going to do it this way. And again, we're going to do the thing by adding the value. Additionally, I know the hot water or the heating supply on Georgia Tech campus is often with steam, and then the building has a converter to go between the steam and then make the hot water for the building. As of the creation of this video, there isn't a way to model that effectively. You can do that in Interview Plus, but it seems kind of needlessly complicated unless you care about the efficiency of the steam to hot water converter. This will provide the total heating demand by the building. So if you have maybe it's 90% efficient, just divided by 0.9, you get the amount of steam used. As an example, and if you can do it after the fact, simply in Excel. So now for the air loop, we can double click this, and now we're in the air handling unit. And you can change things here, like supply airflow, availability schedule, if there's a night cycle, things like that. You can specify minimum and maximum outdoor airflow rates, how the minimum outdoor air is calculated, if it's proportional, meaning it's based off of time, or the amount of outdoor air that is a minimum changes throughout the day based or off different loads. You can also change the economizer type and how the economizer works, how the set points are. You can change the limit for how high the economizer works. So 65 would be the maximum temperature of the economizer. Let's say you can change that if you want to. You can also specify heat recovery. You can just turn it on, turn it off if you want to. And then you can also change this from like a plate to a rotary, and then that'll give you some latent heat recovery as well. So you kind of get two things. So if you have a total energy wheel, you want to use rotary, and then you have sensible and latent effectiveness. If it's you can also use rotary with just sensible or just latent as well. But considering most wheels are a total energy wheel, that's how that works. For zone groups, the zone group means that every zone, like all these zones, have the same like supply and have the same like heating and cooling design. So if you had like a heated floor or a chilled ceiling, then if you applied it to one of these zones, it would apply to all of them. So if you have like two of these zones have a DOAS, and one of these zones has a heated floor, then each of those zones need to be in their own zone group, and you can change zone groups by editing it and then removing zones that are not the same, adding a zone group, and do that. So let's just say we want to do that for sake of example. So we're going to remove the classroom. Now we have to find 5 zone groups. We're going to go back to the HVAC tab, add a zone group, put it in over here, and then we're going to go back to zone group, and it says you must add a zone, so we're going to click yes. We're going to see what's available. That's the only zone group that's available. So now this is set up. So, and then let's say this has no reheat. This is just So if you want to do something different, VAV no reheat. So this zone has no reheat. So we have to do that. We have to add an extract, which is how the air gets back to the system. Now we need to go to the air loop demand side, and we're going to connect the components just like we did before. So this is the air system. So just match the arrows, out to out, in to in. And now this is set up. So now we have the different zone groups with the different settings. And then the next video we'll talk about how to do radiant systems or more than one system within the zone.